In this video, we will solve a numerical on Baumol's inventory theoretic approach to demand for money. The question is, consider the Baumol's inventory theoretic approach to demand for money demand function. Using that equation, calculate the money demand elasticity of the transaction cost. Options are being given. We need to find out the correct option. Okay. So the Baumol's Tobin model for demand for money is given by, that is, M is equal to under root of T times C upon 2I. Okay. Here M is the average money balance. So it denotes average money balance. Then we have T. T denotes the total value of the transaction. Total value of transaction. C denotes the transaction cost, and I denotes the rate of interest. Now, since we need to find out the money demand elasticity of the transaction cost, so can I rewrite this demand function, this Baumol-Tobin demand for money? We can write it like this, that is T upon 2I raised power 1 upon 2, and let's write C raised power 1 upon 2. Okay, so simple simplification I have done here, so you can check it with yourself how did I made this. Now, since we need to find out the elasticity, money demand elasticity, so let's denote it by E subscript M. So money demand elasticity of transaction cost will be equal to the change in the average money balance due to the change in the transaction cost into transaction cost divided by the average money balance at that very transaction cost. That is, we need to find out the partial derivative, this partial derivative, that is del M upon del C first. That is, we need to differentiate this function with respect to C. Using power function rule, the exponent of C becomes coefficient. So we have 1 upon 2. This term T upon 2I will remain same because we are taking partials with respect to C, and exponent of C will be subtracted by 1. 1 upon 2 minus 1 is negative 1 upon 2. So we'll get negative 1 upon 2. Now we can rewrite it like this, 1 upon 2. Then we have T divided by 2I raised power 1 upon 2. So in place of C, can I rewrite it like this, C raised power 1 upon 2 divided by C, because if I transpose denominator to numerator, it will get multiplied, but the exponent of denominator will get changed. If it is plus, it becomes minus. So let me show how did it sum up to 1. So since if I rewrite this, we have C raised power 1 upon 2, transpose this C denominator, so bases are same, we will get 1 upon 2 minus 1, which is again C raised power 1 upon 2 but negative. Okay, I have done this purposely, so let me show the purpose here. So can we rewrite it like this, 1 upon 2, we have C raised power, if I transpose this or take this into this function, so we will get T C divided by 2I raised power 1 upon 2, this C, and we have 1 upon C here. Okay, so this function, this term, as we know, it is the given function, so we will have 1 upon 2. In place of this, we can write M, and we have C here. Okay, this is this derivative. Let me see if I am within the limits now. So elasticity of the transaction, money demand elasticity for transaction cost will be equal to, so del M upon del C, we got it 1 upon 2 M upon C. So we have here C upon M. So CC gets cancelled, MM gets cancelled. We are left with 1/2, which is equal to 0.5. That will be our money demand elasticity of transaction cost in case of Baumol Tobin inventory theoretic approach to demand for money. I hope I make myself clear in this video. Thank you.